Seeing things like a hurricane develop in its earliest phases, getting a much better idea of its strength than we can from flying one or two planes through it. We can map the entire surface effect of a tropical storm in one pass. The ISS-RapidScat is a mission to bring a payload to the International Space Station, and from there we will observe the Earth's oceans and be able to map the speed and direction of winds near the surface.
RapidScat is a scatterometer. It's a radar. It sends out little bits of energy towards Earth's surface that then get reflected back.
If the ocean is flat, most of that energy from the radar just scatters away.
The stronger the wind, the rougher the surface will be, the more energy will be returned to the radar, and then we can convert that energy into a measurement of the wind.
And that'll help us do things like track and predict severe storms, and also learn about the ocean-atmospheric interface.
Especially over the tropical regions, which are of great interest to the United States, because most of the tropical hurricanes that hit the United States come from those regions.
We're launching on a SpaceX Falcon 9 rocket.
The Dragon capsule separates from the Falcon 9 in orbit.
And after orbiting Earth a couple of times, the International Space Station robotic arm reaches out and gently grabs the Dragon as the Dragon, slowly approaches the ISS.
About 2 days later, ground controllers bring the robot arm over.
The robotic arm then reaches into the trunk and grabs the instrument and plugs that onto the International Space Station.
And everything mates robotically. We hook these pieces together and then we get to stay on the outside of the space station for a couple of years. The space station came and asked what relatively inexpensive payloads we could put up on the space station.
We had this hardware sitting there doing nothing, collecting dust for the last 13 years. We might as well try to put it to use.
What if we took some of the existing hardware and tried to fly it in the simplest way possible?
We've put them through extensive testing, electrically tested them, vibration tables, thermal vacuum chambers.
And that leftover hardware meant that we got to save about 80% of the cost in terms of being able to reuse the hardware instead of building new.
And we've added the necessary adjustments needed for this new orbiting platform that we'll be on.
The space station is built out. We know what the external capabilities are. We know we can put science instruments in different places.
We're taking something with a very small team, a very small budget, and a very short schedule, and turning it into something with very real science value.
The global coverage of the Earth is probably right now one of the greatest priorities that people should have in mind when they think about the importance of the space program.
The Earth is a very dynamic, very complex system. And because of the role that winds play, it's a fundamental part of that whole story.
And we need people's awareness and understanding of the importance of NASA's mission to help understand how our climate is changing.